share my screen. Okay, before I come to the introduction slide, so I want you to have a look with this one. This is your team, right? Okay. Yeah. Can any students unmute the mic and let me know that you can see my screen? So I'm now in the team.
Yes, we can, Miss.
Yeah, can see.
Okay, thank you very much. Okay, now, so this is your team that I created for your EMTS classes. So there's a general channel, okay? And then for the classes, I will create new channel, okay? For week 1, week 2, week 3, and so on, right? Okay, so for general channel, mainly we'll use it for the announcement, right? So for example, so I will announce when is your your quizzes, okay, your assessment, and all announcement I will make in the general channel. Then for the classes, I will create the channel for week 1, week 2, and so on. So for week 1, okay, I put 2nd August. So 2nd August is to indicate the Monday of the week 1. Okay, so it will be easier for us to know which week are referring to. So I think it's good to have a week 1, week 2, week 3. I think every one of us will also alert that, oh, we are currently in week 1, we are in the week 2, week 3, and so on. And another reason is it will be easier for students, okay, because your recorded video will be for week 1 classes will be all under the week 1 channel, okay, will be all under the week 1 channel. And for your information, right, nowadays the classes, as you know, all classes I will record it, and those recorded classes, right, is not going to be in the stream anymore. It will be after the class, right, it will be part under the file. So for example, right now I schedule the meeting under week 1, right? Okay. So after the class finish, after I stop the recording, okay, I end the meeting, then the recorded video, it will be part under file of that particular channel. So can you see for different channel, there is a file folder on the top, right? And there are different file folder. So general, we have file also. For week 1, we also have a folder of files, okay, on top of the team. So the recorded video will part under the file, okay, for your information, okay? And will be easier if I put it by weeks, okay? Then it's easier for you to access to the video. Okay, then now come to the general folder, okay? So for general folder, right, okay, if you click the file folder, there's a folder for class materials, okay? So for all the team, there's a class materials folder, okay? They already created a class material folder. So for your information, all the materials, right, is already in your Moodle, okay? All the materials is already in the Moodle, but that is the materials from the module leader, okay? But sometimes I edited the material. So for those edited materials, then I will part under the class materials, okay? Class materials in the file folder for general channel, general channel. So if you click in, you can see there are 2 folders I just created for slides, and I just uploaded the 2 slides for introduction, the edited version, and also the first topics for introduction to trigonometry, also edited slides, and already uploaded here, okay? So after the class, if you can refer to these slides, okay? So I think for the for the trigo, I edited quite a numbers of slides, okay? So instead of referring to the one in the Moodle, you just take these slides from here, okay? If I don't upload any edited slides, okay, then that means the slides I'm using is the same as the one in the Moodle, okay? Please take note. Okay, then another folder is for tutorial. So I also upload the tutorial for first chapter. And this is, I don't edit anything from the first topics. Tutorial is quite many questions already, so I don't edit any. Okay, so but I will just upload here, okay, for your reference. Okay, now, so we are done with the general channel, okay? Then come to the channel for week 1, okay? So every week we have 2 classes, okay? If let's say not affected by holiday. So for today is a tutorial class. For tomorrow, I'm going to see you again on 3:15 to 5:15, which is a lecture class. Okay, since you only have 15 students, we have 1 lecture, 1 tutorial class. So and both classes is actually 2 hours. So it doesn't matter whether today is a lecture or today is a tutorial. Okay, since it's only 1 group, so I may just conduct a lecture during tutorial class. I may just conduct tutorial during the lecture class. Doesn't matter. Okay. Okay. So for every week, okay, definitely I will conduct lecture and tutorial. So any classwork for that particular week, you are supposed to upload under the files, right? So if you look at the files folder for week 1, I have created 2 folders, which I created the folder for 2nd August and 3rd August because we have classes on 2nd and 3rd. So if let's say today we have any of the classwork, so maybe classwork means maybe for lecture, when I lecturing, I give you some activities to practice. Then after you practice, right, those questions you need to, those solutions from you, you should upload here. Okay, and then it will be better if you name your file with your name. Okay, the file name with your name, that will be easier. But of course, I also can see who are the students who uploaded the files here. Okay, okay, then please upload your classworks here and including the tutorial. So so when come to tutorial class, I will discuss some questions. Okay, and maybe some questions not being discussed, but of course, all students required to finish the tutorial question. So those solutions, you are going to upload it here. So what is the reason? Okay, so for your information, of course, I can't do marking. Okay, I can't do marking for students' classwork. Okay, because I have quite a numbers of students. Okay, like last semester, I have 300 plus of students. Definitely, it's not possible for me to do any marking. But why I require students to upload here? Okay, first thing, students, all the tutorial questions you need to practice. This is one thing. Second thing, okay, so this is a commitment, okay, your commitment to yourself, okay. So I require to upload, so sometimes students are more keen to actually practice the questions, okay, and you're supposed to do it, okay. And then I will also like to see, okay, students, whether you are doing your work. So I may randomly check, okay. So sometimes I will check, okay, whether students submit the work, okay. So for maybe some questions, if I don't discuss whether you know how to do it, I may also randomly check, okay. So that's why I want you to upload your classworks here, okay. So and you know, when come to mathematics, you should not just listen to my explanation, just watch the recorded video. Maths require a lot of the practice. Okay, when you watch it or when you practice it, it's different, right? It's like how when you do your exercise, okay, workout. So of course you will get healthy if you do it, the exercise, instead of you watching of people doing the exercise. So we all know when come to the mathematics, practice means perfect. Okay, so I don't think students can do well without practicing any of the questions. Okay, okay, so now anything you want to ask about your team before I come to the slides, introduction slides? Any questions you want to ask about the team?
Hi, Miss. Can you hear me?
Yes. Yeah.
Yes.
Yes.
Yeah, I got a question. Like the working, right? You write the answer down or you take the picture and you upload to a document.
Oh, okay. So for your convenience, I definitely students they will do you will do your solution on a paper, right? So you can just snap the photo of your solution and upload. Okay. So or if let's say you some students they're using a pad, digital pad or iPad or anything, you can just upload the files from your pad. Okay, and then yeah. So anything that is convenient to you, you don't need to type. Okay. And since you are taking MTS last semester, so I believe when you submit your assessment, you are taking the photo. Okay. So in the classwork that upload into the team, I can accept image file. But of course, when come to the assessment submission in the future, you have to submit as a PDF file. There's a reason why I require PDF file. That is another story. I will mention it in the future. Okay, but for now, for the classwork, you can just give me an image file. I'm fine with that. But since we have 15 students, so if let's say your image file is only one, then it's okay. You just upload one image file. But just in case you have a few images, so instead of one person, maybe you alone, you uploaded 10 image files here, then I will prefer you to put it in a folder or put it under one file and submit. So one file submission from each student, okay, it will be better. So either you create your folder here with your name, okay, or you can put all the images as one file and upload here. Okay, is that clear? Cheng Hao, right?
Yeah, clear.
Okay.
Hello, ma'am. I have a question.
Yes. Yes. You
Ma'am,
are Saad.
ma'am, when we are having a exam and assessment, so we have to submit our test in Moodle.
Okay. Yeah. Okay. All the assessment will be conducted in Moodle and submit in Moodle. So I think for your MTS last semester should started already, right? Your MTS last semester already started with Moodle submission, right?
Yes, ma'am.
Yeah. So yeah, since I think definitely for your batch is also the same. Okay, then there's a questions from Samuel. Microsoft Word with images can, right? Okay, for the submission of classwork, yes, can, Samuel. Okay, for submission of classwork, can. But for the submission of the assessment, as I say, I will require PDF file, and there's a reason why I require that. I will explain it in the future. Okay. Okay. Then now let me go to your introduction slides. Okay, so this is a introduction slides regarding engineering maths. Okay, so yeah, okay, you can see my name, right? Okay, and my email address. Okay, so you can see my email address. But since we are using Teams as a platform, so students will seldom send me email. So if you can actually send me message in the personal chat, okay? If you want to contact me, right? Okay. And you can see right now everybody is working from home, okay? And there's no prerequisite for this module, okay? And the aims of this module contribute to the achievement of the learning outcomes as specified for the students award and foundation level, and provide an introduction, the study of mathematics. Okay, and as I say just now, okay, this is a background knowledge for your other engineering maths module in the future for your level 1. Okay, so I think for level 1 you have quite a numbers of engineering maths. Okay, engineering maths 1, 2, 3, and there's another engineering maths. Okay, but I know there are some changes made. Okay, so I think roughly 3 or 4 engineering maths modules in the degree. Okay, then introduce and begin to develop lifelong learning skills of independent learning and study in relation to maths. Okay, so nowadays we want the students to develop the lifelong learning skills. Okay, so this is very important. Okay, So you should have that lifelong learning skills until you get old, even after you finish your study in university, right? That is important. And these are the two learning outcomes of the engineering maths. The first one, comprehend the fundamental concepts of the engineering maths, okay, and solve the problems related to engineering mathematics. So these are the two learning outcomes for the module, okay. And these are the mapping of the course learning outcomes that I showed you just now with the MOE's domains. Okay, so which is the Ministry of Education domains. And what are the two domains I'm referring to? So there are domain 1 and domain 7 here. Okay, the two learning outcomes mapped to the two domain. So if you refer to here, okay, the 1 and 7 which are referring to number 1 is the knowledge, okay. So that means to study this module, you will gain knowledge about engineering maths. And for the 7, which is numeracy skills, because this is a mathematics module, so you will obtain numeracy skills. Okay, so when you look at here, the domains for the MOE, okay, so these are the domains, right? So all these domains, can you see, is not only about knowledge and numeracy skills, okay? There are some others skills such as interpersonal skill, communication skills, digital skills, and so on, right? Okay, so other skills is also very important because in the futures, after you finish this, you go to degree, and after you finish, say you go out to work, other skills are very important also. So communication skills, for example, so when you work, you need to communicate well for others, right? Okay, with others. So when you present, when you communicate with, you want to present something, a project to your client, to your colleagues, to your boss, right? So you need all the skills here, interpersonal skills, communication skills, and of course nowadays digital skills are very important as well. So this is just some examples. Okay, now let's go to the next one. Okay, so how about the teaching strategy? So because this is a mathematics module, so demonstration part is very important. So of course, all the calculations, I will demonstrate the calculation, and of course explain those concept, theory before I demonstrate how's the calculation. Then I may ask questions to students, and then students answer it, okay? So that I can know whether students understand or not. And of course, students can also ask me questions. Okay, and the learning activities are mainly like a listen, take notes, ask questions to clarify doubts. So when you attending the class, so you take notes, okay? And when there's classwork, when there's activities, you need to practice the questions, right? If you don't understand, you can ask the questions. Okay, then for tutorial class, so after I finish the lecture class, I will tell you which questions you can practice from your tutorial, okay? Then for most of the tutorial questions, I'm going to discuss in the tutorial class, okay? And so far for your tutorial questions, there's no answer. Then when come to tutorial class, I will provide you the answers, okay? If I forgot, please remind me, okay? So for those questions, especially those questions that I don't have time to discuss, so normally those I don't discuss is a slightly easier question, okay? And normally those similar questions already discussed, okay? Some I will let students to practice it themselves. So those questions I will definitely provide answer. So if I forget to provide it in the class, then you have to remind me. Okay, please remind me. Okay, then of course, if the students have a doubt on the tutorial questions, I will demonstrate it during the class. Okay, and so for learning activities, students will practice tutorial questions, solving problems, ask questions to clarify doubts, discuss with peers, demonstration on the board, receive feedback. So this demonstration on the board is referring to the physical classes. Okay, so in the online classes, okay, so since this is not the first time you're taking maths module, so your lecturers in the past may doing the same thing. So for me, I will ask students to maybe snap the photo of the solution, right? So normally students will do it on the paper. So I will ask the students to snap the photo of the solution and post it in the chat box. Okay, so let's say in the class. So sometimes I want to see, okay, how you solve the question. Then I want to get students' feedback, okay, how students solve it. Then sometimes I will ask students some questions. So a simple one, students will answer in the chat box. And if I want the students to show me the solution, students will snap the photo of the solution and put it in the chat box. So that's how I get the students' feedback. Okay. Okay, so this is a very important part, okay, and the main concern from the students regarding the in-course assessment. Okay, so for your information, there are two components, okay, in-course assessment, which are referring to the quizzes, and another component is a final exam. So each components are 50%. So for the in-course assessment, the quizzes portfolio is, there are 4 quizzes here. Okay, for your information, right, we may have changes on this assessment. Okay, soon I will update you all again. Okay, so now I'm updated you on the assessment that have been practiced for quite some time. But recently, we may have a plan on doing some changes on the assessment. Okay, so I will update you if the changes are confirmed. So tentatively, we look at these components first. There are 4 quizzes here. So first 2 quizzes are assessed on the same topic, okay, trigonometry. And next 2 quizzes, quiz 3 and 4, we are going to assess on second topic, which is matrices. Okay, but of course, we are going to ask something different, okay? Even though I come from the same topics. So for the first quiz, okay, we are expected to carry out on week 3, okay? Then with the weightage of 10%, okay? Then for second quiz, okay, we will carry out in the week 5, okay, for 15%, 10%, 15%. Okay, so that means from first topics, the assessment will be about 25%. Okay, then for quiz 3, chapter will be in week 7, okay, 10%. For quiz 4, in week 9, okay, another 15%. And so these are the 4 quizzes, okay, and okay, yeah, 4 quizzes, okay. Then your final exam will cover topic 3 and 4, 50%. So you can see we have chapter 1, 2, 3, 4, only 4 chapters, okay, for engineering maths, okay. But on average, since your foundations is 12 weeks, so on average, engineering, we spend about 3 weeks for each topic. Okay, about 3 weeks for each topic. Okay, so for your assessment, I may conduct during the class times, or if let's say I found that the class time is not enough time for conducting the assessment, then I may conduct it outside of the class time, especially if there are some classes affected by holiday. Okay, then I may conduct the assessment during outside of the class time. Okay, for your information. Then for final exam is another 50%. Okay, for 2 topics. Okay, so you can, okay, so this is something further about the summaries on the quizzes. So for your information, 30 minutes for each quiz, okay? 30 minutes for each quiz, okay? So since quizzes, so the time for the quiz is normally 30 minutes. So if you have taken the quiz in the last semester, I think your quiz is also 30 minutes for your mathematics. Okay, then, yeah, okay. Any questions you want to ask about the assessment? For your information, all the assessment are structure question. Structure question. Any questions you want to ask? No, okay. Okay, so quite clear, right? Okay. Okay, just update you a little bit on the, okay, just I say all assessment are structure question. Just update you a little bit on the format of the final exam. So final exam, as we know, as usual, will be 2 hours. And the total marks is 100 marks, right? Okay, 100 marks. The paper, okay, 100 marks. And there are 4 questions, all compulsory questions. So 20 marks, 25 marks each for each question. Okay, all compulsory questions, 25 marks each. Okay. Okay, next one. So for your lecture and tutorial, each one of them are 2 hours. Okay, so I'm seeing you once for lecture and tutorial per week, and the independent learning time is 52 hours. So what is means by the 52 hours of the learning time? That is independent learning times, that is referring to the time you spend to revise the slides, practice the tutorial questions, do some online study, okay, sample assessment questions, okay. So all these are the independent learning time, okay. Okay, so regarding the methods of the delivery, so we are now moving from the traditional topic-based teaching to the outcome-based education. Okay, so I think you should have seen this in your last semester, EMTS. So what it means by outcome-based education, which is OBE? So it's an education based on producing particular educational outcomes that focus on what students can actually do after they are taught. Okay, and we expect all learners or students to successfully achieve particular or sometimes minimum level of knowledge and abilities. Okay. And so regarding OBE, it is not what we want to teach. It's not what lecturers want to teach, but it is what the students should learn. Okay? Okay, so these are the 4 topics that we will cover in engineering maths. So as I mentioned just now, on average, each topic we will spend about 3 weeks. Okay, so we'll use 3 weeks to cover each topics around. Okay, so first topics will be trigonometry. So later I'm going to start with trigonometry, matrices, complex numbers, and vectors. Okay, so I believe I can't remember. Okay, I think you have learned about trigo in your high school, trigonometry, matrices as well. Complex numbers, I don't think so, right, in your high school study. And then vectors, is it vectors you cover in physics, but it's not in mathematics? Am I right? Okay, am I right? So do you learn complex numbers in your high school study? Yes or no? No. Okay, complex number, no, right? Okay. Okay, vectors, vectors? Vectors? Vectors in additional maths, a little bit, okay? Okay, so I believe maybe what you learn here will be slightly further. Okay, so that means complex numbers should be something quite new to you, totally new to you. Okay, so trigonometry, I think most of the content from trigonometry you should learn in high school. Okay, for matrices, part of it. Okay, but certain topics content is totally new to you. I'm quite confirmed. Okay, certain content is new to you, totally new to you. Complex number is totally new to you. The whole topics fractals a little bit. Okay, can. Okay, so thanks for the feedback. Okay. Okay, so these are the rules, okay, but it's more applicable when you are in the campus, okay. So maybe I can skip this. Okay, then, okay, regarding the consultation hours, if you have, okay, normally since your group is small, okay, it's not like, I believe last time you are in MTS, then you're going to have many of your friends in one class. Okay, but MTS, I think you have lecture class is actually 60 plus of students, but there are many lecture group. Okay, there are many lecture groups. So actually, sometimes MTS, in the total students may be 200, but they split by lecture group. So for each lecture won't be very big. Okay, it's like 60 plus of students. Okay, for example. Then tutorial class will be about 30 or 20 plus of students, okay, 30 or maximum 40, right? Okay, so for EMTS is quite, for example, your group is 15 and I have another, your senior group is about 19 of them. Okay, so it's considered small. So if you have any doubts, try to actually clarify during the lecture class and the tutorial class. Okay, so since the group is quite small, so I think should be no issue. Okay, but in case you have um, questions, okay, after the tutorial class, you still have some questions, you can actually ask me in the personal chat. Okay, but okay, for example, let's say today I conduct a lecture and I ask you to do some tutorial class. Okay, before come to the discussion of the tutorial, if you have a doubts, please hold on first. You can wait until tutorial class and ask me. Okay, so you don't need to ask the questions that if you have a chance to clarify with me from during the tutorial class, so you don't need to chat with me in the chat box. So just wait until tutorial class and clarify with me. Okay, okay, and then there are some internet resources. Okay, actually there are some references you can get it online. Okay, regarding the engineering maths. Okay, so nowadays it's very easy. Okay, videos. You can find it from online, okay, regarding mathematics. Okay, so, okay, this one is your grade points, okay, grade points for your assessment, right, okay, so 50 mark is a passing marks, okay, so just now we can see, okay, your quizzes. I can't tell you the passing mark. Okay, so the passing mark is 50 marks. Okay, passing mark is a 50 marks. I'm talking about the total. Okay, so 50 to 64 is a pass. So 65 to 74 is credit, and 75 to 100 is a distinction. Okay, so if you want to score distinction, then your total mark should be 75 and above. So 75 to 79 is an A, 80 and above is an A plus. Okay, then the passing mark is 50. Okay, below 50 is a fail already. Okay, okay. So this is regarding the grade points. Okay, okay. Any questions you want to ask? Anything? No, okay. So the sample sample assessment questions is also in the Moodle. Okay, sample assessment, tutorial questions, slides are all in the Moodle. Okay, so if you want to know about the assessment that I mentioned just now about the format, right? Okay, you can refer to the Moodle. Okay, the sample assessment are there. Okay, so normally before the assessment, I will also discuss the sample assessment questions. Okay. Okay, so if let's say no question, okay, then I would like to start the first topic, right? Okay, so since our class is 2 hours, so definitely we won't use 2 hours just for the introduction. So I'm going to start the first topics. Okay, so since, okay, it's already 45 minutes since 2:30. Our class is 2:30 until 4:30. Okay, let me give you a short break, 10 minutes break. Okay, so for 2 hours classes, normally I will give a break after the class start about 1 hour. Okay, so since I already done the introduction, and if you have, since you have no questions, then I would like to give you a 10 minutes break. And yeah, make sure you bring your, you have your calculator with you. Okay, so we need the calculator for almost all the topics. We need the calculator. Okay, so please get your calculator ready with you. Okay, I give you 10 minutes break, and after 10 minutes break, then we'll start the first topics. Okay, is that okay, students? Okay, so 10 minutes break. I will normally put a timer. Okay, so everyone aware. Okay, everyone aware the 10 minutes break. Okay, so please come back after 10 minutes. Okay, so I will turn off my mic and camera. See you after 10 minutes. Okay, hi students. Let's continue the class. Okay, so I will take the attendance first. Okay, wait. T4. Okay, today is tutorial class. Okay, take the attendance. Okay, 2 absent. That's why I thought all present. 1 absent. Let me see. Samuel? Samuel, are you here? Okay, taken already. Okay, all present. Okay, now let's continue with the first topic. Okay, we start with our first topics today. You can get edited. This one is an edited version of the slides, so you can get it from general channel. Okay, so what we're going to go through for this first topic is an introductions to trigonometry. Okay, and these are the contents that we're going to cover, the trigonometric function. So about the sine, cosine, tangent. Okay, then there are some elevation, some other terms that you need to know, such as elevation and depression angle, sine rule and cosine rule. Okay, of course, when it comes to trigonometry, it's about the triangle, right? So we will go through some rules to solve the triangle, and also those trigonometric identities. Okay, there are some relationship between the sine and cos. Okay, are all given as a trigonometric identities. Okay, then the last is a solving trigonometric equations. Okay, so these are the topics that we will go through. Okay, then the learning outcomes for this topic. Okay, we should able to use a trigonometric, the knowledge from trigonometry to solve engineering problems. Okay, and now, okay. So let's look at this slide. Okay, intro to trigonometry. So trigonometry is the branch of mathematics that deals with the measurement of sides and angles of triangles. Okay, and the relationship with each other. So when it comes to trigonometry, then we talk about the triangle, right? Each side of the triangle, okay, and the relationship with each other. Okay, and there are many applications in engineering where knowledge of trigonometry is needed. So later we'll go through some of the application. So the importance of the trigonometry, so I'm showing 2 importance here. So first, okay, So it's regarding the alternating currents and voltages often can be described using the trigonometric function, right? The alternating currents and voltages and modeling of the waveforms, okay? So these are the importance of the trigo. And there are some applications, okay? You can see some examples. Engineers use the fundamentals of trigonometry to build structures or systems, design bridges, solve scientific problems, etc. And other applications such as music, video games, construction, marine engineering. So these are some other applications for trigonometry. Okay, okay, now, so let's start with the first things about the about triangle before we go to trigo. So which is regarding the theorem of Pythagoras. So because theorem of Pythagoras we apply on the triangle, right angle triangle, right? So that's why we start with this one first. Okay, and now can you tell me what is means by right angle triangle? Can you still remember what it means by right angle? What it means by right angle? Any one of you? (90°), yes, correct. Okay, right angle is about 90°. Okay, so right angle is about 90°. Okay, so for a 90-degree triangle, when we say right angle triangle, means 90-degree triangle, and there is examples here. So you can see this triangle, one of the angle is 90°, okay? Okay, when you have a right angle triangle with a 90°, then you can actually apply the theorem of Pythagoras, okay? You can apply the theorem of Pythagoras. Okay, so about the theorem of Pythagoras, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So where is, okay, this one is the square of the hypotenuse. Okay, where is the hypotenuse? Okay, so when you look at the right angle triangle, so the opposite side of the right angle, here, this one is a hypotenuse, right? Okay. So when we draw the triangle here, okay, just for your recap, how we put the notations for the triangle, okay? This is somehow also important because later when come to some of the formulas, you need to understand the notations that we use. So normally when come to the triangle, we using a capital letter to label, okay, the triangle. So as a A, B, C, okay. Then for the side, we will label it as a small letter, right? Okay, the small letter. So for example, here is a capital B, right? The opposite side we will put as a small letter of B. So here is a A, right? Okay, so maybe let me change the different color. Okay, so you can see it clear. Okay, so let's, sorry. Okay, so say this is A, then the side of A, we label it as a small letter. Okay, then for B, right, the opposite is the side B, small letter. Okay, then for this one, C, right, the opposite side is a letter or small letter of C. Okay, so that's how we label the triangle. So we'll apply to the same if we deal with other notation. Let's say instead of you label a triangle as ABC, we label it as PQR, right? Okay, it's also the same things, okay, how we actually label the sides. Okay, now, so for these triangles, right, okay, so the hypotenuse, which is already highlighted as a yellow color, is a B square equals to A square plus C square. Okay, the sum of the square for the sides, two other sides. Okay, B square equals to A square plus C square. Okay, so if we want to find the values of the side B, the hypotenuse, we can, since just now the relationship is in the square, B squared equals to A squared plus C squared. If I want to find B, then I need the square root. Okay, square root for the sum of the A squared and also C squared. Okay, the square root of the A squared and also C squared. Okay, then if you want to find the other side, okay, so hypotenuse is B equals to square root of A squared plus C squared. But if you want to find other side, then how is it? Okay, so for example, you want to find the length of side A. Okay, then A squared, if you need to rearrange the equation just now, so will become A squared equals to B squared minus C squared. Then for this case, if you want to find the length of the side A, then will be the square root of B squared minus C squared. Okay, so say you want to find another side of C, right? From the equations here, C squared is actually equals to B squared minus A squared. Okay, then your C is actually equals to square root of B squared minus A squared. Okay, so that's how you find the other side. Okay. Okay, so I think this is quite an easy theorem. Okay, most of you should understand this one, right? So let's look at some of the problems that we can solve by using the theorem of Pythagoras. So for example, the problem one that you can see right here, okay, find the length of BC. Okay, so length of BC, where is the length of BC? So you can see this triangle, right? Length of BC is here. So which is the hypotenuse? Okay, the A. So the rest of the sides already given, okay, which is the side for B, 4 cm, side of C, 3 cm. Okay, so we can find the side of the A. Okay, so as I say just now, according to the theorem of Pythagoras, A squared is equal to B squared plus C squared, right? Okay, so if you substitute, okay, the side of B, which is 4 squared, then the side of the 3 squared. Okay, so when we total up, we get 25. Okay, to get A, you need to find the square root of 25, which is giving you 5. So that means the length of the A is actually 5 cm. So that's how we solve it, okay, using theorem of Pythagoras. But you have to remember, theorem of Pythagoras can only apply, okay, when you have a right angle triangle. One of the angle is 90 degrees, then you can only apply it. If let's say they are not a right angle triangle, then you can't apply the theorem of Pythagoras. Okay? Okay, so this is a triangle with the sides of 3, 4, 5. Okay? Okay, is that okay so far, students? A simple problem. Is that okay? Yes, okay. Now, let's move on. Okay, so we have another examples here. Okay, so this time, the Pythagoras is already, the length of the Pythagoras already given, the length of the hypotenuse already given. So can you tell me which side is the hypotenuse? Which side is hypotenuse? E, correct. Okay, this one is hypotenuse. Okay, so for hypotenuse is already given as 13 cm, right? Okay, so now they require you to find the length of the EF. So length of EF is actually D. Okay, length of EF is actually D. Okay, so according to the theorem of Pythagoras, E squared equals to D squared plus F squared, right? Okay, so you can substitute the E as 13, right? Okay, then your F is a 5 squared. Then your D squared will be equals to 169 minus 25, which is 144. So to find D, you need to find the square root. Then square root of 144 is 12. So that means the length of the D is actually 12 cm. Okay, So this is a right angle triangle, okay, with the length of the hypotenuse given and another side, which is you try to use the theorem to get the length of the side B, right? Okay, so 12 cm. So this is a triangle with 5, 12, 13, okay? The sides of 5, 12, 13. Okay, so is that okay so far for this example? Okay, right? Okay, then let's go to another question. Okay, so we look at some of the problems here. Okay, so how we use the theorem to actually solve some of the problems. Okay, now for problem number 3, two aircraft leave an airfield at the same time. So one travel due north, okay, at an average speed of 300 kilometer per hour, and the other due west, okay, at an average speed of 220 km per hour. So the speed is given. Calculate the distance apart after 4 hours. Okay, so let me highlight some important things here. Okay, so okay, the 300 km per hour. Okay, and the other due west at 220 km per hour. Okay, so this one is due north. Okay, this 220 is due west. Okay, then calculate the distance apart after 4 hours. Okay, the distance apart after 4 hours is distance apart of the two aircraft. Okay, the distance between the two aircraft after 4 hours. Okay, now, so can you see, okay, since you need to find the distance apart after 4 hours, then what is the distance traveled by each aircraft after 4 hours? Okay, so for the one of the first aircraft, right, is traveled by 300 km per hour. So since 4 hours, so what is the distance? So you need to times 4. So what we can understand, 300 km per hour, that means 1 hour is actually travel 300 km. So 4 hours will be 1,200 km due north, okay, to the direction of the north. This is the first aircraft. Then second aircraft, okay, the speed is actually 220. So 220 km per hour means 1 hour is travel 220 km. So 4 hours means it's 880 km and is towards the direction of the west. Okay, you can see north and west here. Okay, so now, so this is a distance. Okay, so we can actually from the distance here, we draw a triangle, right? So we involve a right angle triangle because for first aircraft is towards the north. So this is north, right? And the direction is north and the distance is 1,200 km. And the other aircraft is towards the west, right? So with the distance of 880 km, right? 1,200 and 880, okay? So the direction of the north and west is with the 90 degree, right? Okay, so that means here, right, after you draw out the length of 1,200 and 880, right? So now this is considered of the position of the two aircraft. So this is the position of the two aircraft. So you need to find what is the distance apart between the two aircraft here. So you need to find this length. Okay, okay, now you have a right angle triangle, so you can actually solve this using the theorem of Pythagoras, right? So this is a hypotenuse, okay? So by using theorem of Pythagoras, right? So you can find there's a relationship, okay, which is a BC square equals to 1,200 square plus 880 square. Okay, so you take the sum of the square for each number and you manage to get 22, okay. Sorry, it's not 22,000. Okay, so this is your answer, right? 2214400. and then you need to find the square root if you want to find BC. So to get the square root, then your answer is 1488. Okay, let me check, is it the exact figures? Okay, square root of 2214400. Okay, so your answers is actually decimal. Okay, it's actually decimal. So if let's say we put in the whole number is 1488, okay, 1488. Okay, so this is the distance apart the two aircraft, which is 1488 km. Okay, we put in the whole number here. Okay, so you can see how we use a theorem to actually solve the problem. So is that okay for this question so far? Is that okay? Yes or no? Yes, okay. Okay, then we can move on, right? Okay, so I have an activity for you, okay? So this activity is about the theorem of Pythagoras. So let's do it right now, okay? All of you, okay? Do it on the paper. Later, I may ask some of you to snap the photo of your solution. So I give you about 5 minutes. And before we move on, right? Okay, because I'm giving you two questions here. Can you see there is a, okay, sorry. Can you see this term? Can you recall back what it means by isosceles? When we say a triangle is isosceles means what? Any of you can recall back? Yeah, okay. So for the triangle with three sides, right? Two sides are equal length. Okay, two sides are the same length, correct. Okay. So because you need to understand this one, okay? Two sides with same length, correct. Okay, so for example, let's say this is, I just simply, okay? So let's say this is a B, C, okay? That means two sides with the same length. So for example, let's say this one 3 cm, this one also 3 cm, just for example, okay? So of course, when two sides are the same length, right, then the angle will be the equals also, okay? So if let's say these two sides are the same, then of course the two angles will be the same as well. Okay? Okay, now you carry on. Okay, continue. Continue the question. Okay, so it's about 5 minutes already. Have you done? Let me see. Okay, so I can see some of the answers from students. Okay. Okay. May I know who have done the questions, both questions? Can you please raise your hand? Is it all students already done? Raise your hand, please. For those already done, raise your hand, please. Okay, Sa say you're facing difficulty in question 2. Okay, for those having the difficulty for questions 2, doesn't matter. But for those you already know, if you're already done, raise your hand, please. Okay, if you have problem with questions 2, it's okay. Okay, but at least you already tried. So I want to know, for those you already know whether you have done. Only 2 students done? Okay, so, okay, it's okay, put your hands down. Okay, first question, who already done first question? Who already done first question? Raise your hand, please. No, questions 2 is not required rules because I haven't go through the rules, so I won't ask you to use a rule. Okay, I won't ask you to use some things that we haven't go through in the class. Okay, so 12 students. Okay, done. It's okay, thank you. Put your hands down. Okay, so maybe we have a discussion. Okay, for the questions, put your hands down. Okay, if I give you some activities, I will not ask some things that I haven't teach, okay? Normally, okay? Okay, so before I continue, what does it mean by Q is right angle? Criticon, I think just now in the class I mentioned, right? Okay, so can you see earlier? Can you see it here? At the beginning of the class, I mentioned right angle triangle. What is means by right angle? Okay, right angle means 90 degree. So this is a right angle triangle. Okay, am I pronounce it correct? Criticon. Do you get it? Okay. Okay. Correct. Okay, now back to the questions just now. Okay, so for the first question, okay, can I have, wait, hold on. Okay, so this is our first question. So make sure you label the triangle properly. So because I found some students, when they draw it wrongly. Okay, so for the first one, right, in the triangle of CDE, okay? So let's say CDE, right? And they say D is actually 90 degrees. So that's why I draw it as 90 degree here. Okay, right angle triangle. Then CD, which is the length of CD, is actually 14.5 83 mm. So let's say this length is a E, this one is a C, this one is a D. So E, which is CD, we indicate as a CD or we put as a E, 14.83. Okay, then CE, which is a hypotenuse, okay, 28.31. Okay, determine the length of DE. Okay, so that means you need to find this length. Okay, so since this is about the triangle, right angle triangle, right? So we can solve it using the theorem of Pythagoras, right? Can I have a student to show me the solution? Okay, can I have Samuel? Can you snap the photo of your solution for number 1? Samuel, can you post your solution? Samuel, are you here?
Yeah, I have already sent him.
Okay, so I saw already. Okay, yep. Okay, so this is a solution from Samuel, right? Okay, so if we want to find the CE, all right, DE, okay. So DE is actually equals to square root of, okay, D square minus E square, right? So D square is actually 28.31. Then E square is actually 14.83 square. Yes, correct. Then the answer is 24.115. 24.115. If you put in 2 decimal places, will be 24.11 nm. Okay. Okay. Yep. Correct. Okay. So next question. Okay. So next question, the answers is actually 27.2 cm for part A, and then the angle is 45 degrees. Okay. So let us have a look at this question. Okay, so for these questions, triangle PQR is isosceles. So as I say just now, with the same length, 2 sides with the same length, and Q being a right angle. So that means Q is the 90 degree, right? Okay, so if I draw the triangle, so since Q is 90 degree, so that means, for example, PQR, right? The Q is 90 degree, okay? And, okay, Q is 90 degree. Then since it's isosceles, okay, that means these 2 sides will be same length, okay? These 2 sides will be same length. If these 2 sides is same length, definitely these 2 angle will be the same angle. These 2 angles must be the same, right? Because the 2 sides are the same. Okay, so now the hypotenuse is 38.47 cm. So the hypotenuse is here, right? So this one is Q, huh? Okay, 38.47. Can you see I label as small letter? So the opposite of the P here is a small p. The opposite of the R is a small r. So this is a length of the triangle. Okay, so find the length of sides PQ and QR. Okay, PQ and QR. Huh? Okay, so now, okay, how we solve this? Huh? Okay, now, so as we know, okay, the relationship between the three sides of the triangle supposed to be Q squared equals to R squared plus P squared. Okay, R squared plus P squared. So since they are the equal length, okay, so that means R is equals to P. So let's say, assume the length is X. Okay, they are the same length, right? Okay, so that means the Q square is 38.47 square. Then the R's and P, let's say I substitute with X. Okay, so this one solved by using theorem of Pythagoras, right? Okay, so what you have for the x squared plus x squared, which is 2x squared. Okay, then how about 38.47 square? You get 1479.9409. Huh? So x squared equals to 1479.9409 divided by 2. Okay, divided by 2, then what do you get? And you need to find x. So divided by 2, 739.97045. Okay, then find the square root. Okay, which is 27.20 cm. Okay, 27.20 cm. Okay, so okay, if the x is 27.20 cm, then what is the length for PQ and QR? PQ same as QR, same as 27.20 cm. Okay, so can you understand so far? Before I proceed to B. Yes, okay, can, right? I try to show the easiest solution. Okay, of course, there are more than one way to solve it. Okay, here you can see we don't need any rules. Okay, okay, next one is a value for the angle, right? Okay, so this is angle QPR. So angle QPR is referring to which one, right? Angle QPR, so can you see is referring to this angle? Okay, referring to this angle. So can you see the two angles here is unknown, right? Okay, but we know that one of the angle is 90 degree. So, and these two angles are the same, right? Okay, so that means we know that the angle of the QPR is actually, we are taking 180 degree minus 90 degree. So we try to minus the 90 degree here. Okay, then when we minus, we get the rest of the two angles. And since they are same side, then the two angles also the same. So you need to divide it by 2. So 90 degree divided by 2, which is 45 degree for each angle, right? So this is 45, this is 45. Okay? Okay, so the angle of QPR is 45 degree, just like that. Okay? So that means you need to understand the triangle. Okay, then you can solve the question. Okay, so you need to understand some of the term. So is that okay for part B so far? Okay, Yes, huh? Okay, then I will continue here. Okay, so done with the activity. So we will move on to the next slide. Okay, so now come to the sine, cosine, and tangent. So basically, we have gone through this in the high school last time, right? But let me go through some recap. Okay, with a reference to the angle of the theta, can you see, let's say I label this angle as a theta, okay? The angle at A, okay, as a theta for this right angle triangle. Okay, so this is a theta, right? Okay, then this is a right angle triangle. Okay, then can you see how we label each side? So this is hypotenuse. Then this side is the opposite side of the theta, the angle. Okay, and this side we call it as an adjacent side for the theta. Okay, so for your recap, what is a sine? Okay, sine of the theta, which is referring to opposite over hypotenuse. Okay, opposite over hypotenuse. So which we write as a BC over AC. Okay, then for cosine theta, okay, for sine theta, we can write as a in short, which is SIN. Okay, then come to cosine. Okay, cosine theta is referring to the adjacent side divided by hypotenuse. Okay, so in short, we can write as a COS for cosine. So when I say adjacent divided by hypotenuse, which is AB divided by AC. Okay, then for tangent theta, okay, tangent theta is opposite side divided by adjacent side, okay, which is BC over AB, okay, BC over AB, and we can write tangent as TAN in short form, okay. So the abbreviation, okay, this is the recap, okay. Okay, now let's move on, okay. So for the triangles, for example, we have this triangle. The hypotenuse is 13 and the two sides are 5 and 12. Let's say this is the theta. Okay, then what is the sine, cosine, and tangent? Okay, so remember for the sine is actually opposite over hypotenuse, right? Okay, so opposite over hypotenuse, which is 5 over 13. Okay, so this is the values of the sine theta. Then for the cosine theta is the adjacent over hypotenuse, right? So which is 12 over 13. And when you count the value 0.9231, so this is a cos value. Then for tangent theta is the opposite over adjacent. Okay, so opposite over adjacent, which is 5 over 12. And when you count, this is a value. So this is the tangent theta. Okay, clear? Huh? So this is the recap. Okay, now let's move on to another problem. Okay, so we have another right angle triangle, which the two sides are given. Okay, then what is required? You need to find length of AC. So length of AC, which is a hypotenuse. So since this is a right angle triangle, you can solve by using theorem of Pythagoras. Okay, so I think we can go through fast. So AC will be equals to the square root of the square for the 3.47 and the square for the 4.62 plus square of the 4.62. And to find the square root, we get 5.778. So I think this one I don't need to explain in details. Okay. Then sine, cos, tangent, and sine, cos A and tangent A. So you need to find the sine, cos, tangent for C, then sine, cos, tangent for A. Okay, so how are we going to find this? Okay. Okay, so let me shift this triangle, copy this triangle to the next page. So for your reference, okay, So let's refer to this triangle. Okay, will be easier for you to refer, right? So if we refer to C, so can you see this one is for the C, right? Okay, then you refer to the angle C, right? The angle C. Okay, so for the sine, okay, which is the opposite, hold on, just now we need the hypotenuse. Hypotenuse is 5.778, so 5.778. Okay, so let's move on. Okay, so sine C, okay, which is the opposite over hypotenuse, 3.47 divided by 5.778. So this is the answer you get. Okay, next one is the cos C. Okay, so cosine, which is adjacent over hypotenuse, 4.62 divided by 5.778, which is 0.9777996. Okay, so for tangent C, okay, which is opposite over the adjacent, 3.47 over 4.62. Okay, so which is 0.75911. Okay, right? Okay, so now I want you to try for the rest. Sine A, cos A, and tangent A. Let's do it now, okay? Without referring to the answer just now. Just a recap. Okay, you should remember already, sine is what? Cos is what? Tangent is what? Okay? What is written by Samuel? I can't understand.
That was just the high school formula to memorize the sin over opposite over hypotenuse, then cos is what? Is a short form.
Oh, okay. So, okay. I see. High school? Oh, my high school, I don't have this. But I think will be easier, is it? Okay, that's good. Okay, so I believe, okay, but I can't recall my high school. Whether my teacher gave me this, I don't think so. Okay, my time, I don't think so. So your time, yes, you are using that, then is good. Okay, actually we can use any way, okay, that make you easier to understand. Yeah, so in the future we come to the, if we go further, I think, so for examples, we have 4 quadrant, right? Which quadrant sign is positive, negative, and so on. That is also, there's a way to memorize it. Okay, that's good. That's how we use easiest way to actually memorize. Okay, so can I have a students to give me sine, cos, and tangent? Okay, what I want you to do, you have to give me what is a value divided by what value, and then your answer. Please provide me these 3 things. Okay? Okay, so can I have 3 students to give me this one? Okay. Please correct me if I don't pronounce your name correct. Excel, is it? Lin Hua Jia. Okay, can you give me sine A? Benny, give me cosine A and Ella Lam, or should I call Ella? I'm not sure whether I pronounce it correct. Please correct me.
Yes, it's Ella Lam, yes. Ella is the girl name in my country.
Oh, okay. So, what should I pronounce?
Miss Alam will be okay. Alam.
Alam.
Yeah, Alam will be okay.
Alam, okay, thank
Yeah,
you.
yeah. I'll welcome, miss.
Okay. Alam. Benny, I pronounce it right?
Yes, miss, it's okay.
Okay. Benny, can you give me what value divided by what value? Like how Excel put the answer. Benny, you edit your answer. Don't need to delete it, just edit.
Miss, sorry, I was just writing the notes, so I'm not done with the TAN yet.
Sorry?
I was writing some notes, so I didn't do the TAN.
Okay, can you do it now?
Okay,
You just look at the triangle and you just just type the value.
Okay, yeah, okay.
Okay, so by looking at the answer from Excel, okay, for sine A, and Benny, Alam waiting for his answer. Okay, so let's check the answer. So for sine, okay, so which is A? Oh yeah, okay, so this is angle A. Okay, angle A, so opposite over hypotenuse, 4.62 divided by 5.778. Yes, correct. Okay, 0.7796. Okay, then for Benny, cos A will be the 3.47 divided by 5.778, correct? Okay, 0.6. Okay, 0.6. So, or you can put as 0.6006. Okay, if 4 decimal places. Okay, then next one from Alam. Okay, so from Alam, tangent will be the opposite. Tangent A, Alam. Okay, tangent A, opposite over adjacent. So opposite over adjacent. So opposite over adjacent. Okay, so it should be opposite of the A is here, 4.62 divided by the adjacent, 3.47. Okay, so it should be upside down already. Okay, So your answer also affected 1.331. Okay? Okay. Understand, huh? Okay. So it's almost 4:30. Okay. So one last question. Okay, last question for today class. So tangent B is 8/15. Huh? So opposite over the adjacent, so that means 8/15, right? Okay, then determine the value of sine B, cos B, sine A, tangent A. Okay. And in order to find the angle, you need the length of the hypotenuse. Huh? And how to find the length of the hypotenuse? Theorem Pythagoras, because you have a 90-degree right angle triangle, right? Okay, so questions from Saad. Ma'am, we have to give answer in fraction form or decimal form. Okay, here you can give in, actually both also accepted. Okay, both also accepted. But depends on the question also, right? Like just now, since the site is in decimal, so definitely our answers have to be in decimal. So this one for sure. Okay, then for this question, since your site is in the whole number, then it is fine if you give your answer in whole fraction, or it's fine also to give in decimal. Okay. Okay, can I have anyone to provide me the value for hypotenuse? What is the length for hypotenuse? $17. Okay, very good. Yes, it's 17. Okay, then let's proceed for others. Okay, 17 is correct. Okay, it's almost 4:30 already. So can I have okay, so for this case, I want to see the answer in fraction. So I know whether you do it correct or not. Okay, which numbers divided by which number. Okay, so I require sine B, cos B, sine A, tangent A. Okay. Okay, can I have a criticon for sine B? Put in a check box, fraction. So then I will I know whether you get it right or not. Okay. Junho for cos B. Jin Yan for sine A, Wei Huan for tangent A. Okay, Wei Huan for tangent A. Okay, put it in the chat box. Huh? Okay, Criticon for sine B. Given as 8/17. Okay, sine B here. Okay, 8/17, correct. Then who is the next? Junho cos B. 15/17. Okay, correct. Tangent A from Wei Huan. 15/8. A is here. Okay, 15/8, correct. How about sine A? Oh, where's the sine A? Who is given sine A? Who is sine A is 15/17. Yep. Sine A 15/17. Yep, correct. Okay. Okay, so the answers are correct. So I didn't check the answer from Cheng Hao. Okay, so the rest, please check your answer. Right? Okay, it's 4:33 already. So actually the solutions is in the other slides. Okay, the next slide. You can check it out. So just now I already checked, all are correct. Okay, so for what we have gone through today, nothing much you can do for your tutorial, but you can try for questions number 1. Only question 1. Okay, only questions run from tutorial. Okay, so tomorrow maybe I will ask. Okay, so because for tutorial 1, questions 1. Wait. This one can be solved by tangent, cos, and sine. Okay, tangent, cos, and sine for the unknown of the x1 and x2 for the triangle. Okay, because all involve the right angle triangle. Okay, so I think this one should be the easy one. So tomorrow I will ask 4 students to show me the answer. Okay, so is there any questions before I dismiss the class?
Hello, ma'am. We have to do this question as a homework or what?
For these questions, you can put it, for the questions number 1, right? You write it on the paper. You don't need to submit first. Okay, but for what we have discussed today, okay, what we have discussed today, remember just now the slide I asked you to do the activity question and the rest of the question, please upload it in the files. Okay, please upload in the files under the folder of 2nd August. For all the classworks we have done today, the activity, okay, and also the few questions just now. Okay, just screenshot and put it here. Okay.
Which one, Miss?
Okay, so for today, remember just now the activity? The activity 1, okay?
Yeah.
So I already discussed. So please submit it, okay? And just I also ask you to practice this question. Sine A, cos A, tangent A, okay? So this one as well. Cos sine B, cos B, tangent A, sine A, okay? Because just I asked you to do, right? So I believe you have done on the paper. You just snap it and upload. Okay, so because I don't want students come to the class just see. Okay, so if you I can understand if you have no time to take all the notes because okay, I don't really in the classroom, I can't see whether you have done copying, but at least some of the questions that I asked you to do, you should have done. Okay, then you upload this classwork. Okay, to the team.
Miss.
Okay, so Manheng, I think I answered your questions, right? Okay, and for the tutorial, you don't need to submit first. We will discuss it tomorrow. Okay. Okay, is there any questions before I end the class today? Okay, so then nice to meet you today. I will see you again tomorrow. Tomorrow our class is 3 something, right? Okay, I already scheduled the meeting. So tomorrow is 3:15. So tomorrow we will go through the slide, the rest of it. Okay, then I think that's all for today. Okay, bye students. See you tomorrow.
Bye. Thanks, Miss.
Okay, bye.